Welcome guys to an introduction to calculus, and we're going to look at the proof of the first principles. Now we're going to use the concept of the slope of a tangent, and we're going to use the concept of the limit coming through here. So if I start to label some things on this particular point, now if we use our original point, which is y equals x squared, that's our equation. So if we call this point down here x, then the y coordinate at that point is going to be x squared. Right? So if we now use this point up here, we're going to call this point here x plus some value h. Then the y coordinate is going to be x plus h squared. Alright, get the idea? In terms of, so remember to find the slope of a line, we need 2 points to do that. Alright, so if I now equate some of these things down here, bring that down light, drop that down, we can make that into a right angle triangle, can't we? Now, the difference between the x coordinates, we've got x plus h, take x, so this is going to be simply h, that distance there, and this is going to be x plus h squared, take away x squared, and that will be my y coordinate. So you basically have your change in your y, and then you have your change in your x over here. So what we'd be doing in most times, if we start looking at the slope of something, which we generally give the symbol n, that's equal to our rise over our run, so that's now going to be x plus h squared, take x squared all over h. Alright, so that's now going to give me the slope of the line. Now what I actually want is I want the slope of the line technically at this point where we're at x. So I actually want to find the slope of the line at that point there. So what we do is we use the concept of the limit. What we do is we move this h point closer and closer and closer towards the x coordinate. Alright? So we can make h so small that we could say it's equal to 0, but it can never be equal to 0. Alright? So this is how we actually do this. Alright? Now the terminology is f dashed of x, which is in fact the slope of the tangent at x, equals the limit as h goes to 0. And then what we're going to do is we're going to have our thing over here, which is x plus h squared, take x squared all over h. Now what we're saying is we can do that now. Now if I made h equal to 0 in this particular case, then I'll have this whole term over here all over 0, and that would be undefined, so that wouldn't work. So this is what we call a proof. Right? We're using first principles to do this proof for us, but really all we're doing while we're doing this proof is we're finding the slope of the tangent between 2 points. Alright? So let's do it. Let's do it for this particular case where it's x squared. Alright, so we'll set this up. So what I will do, and I've got a cheat sheet sort of done up for you, and I'll just show you that first of all. Alright, there are 3 types of first principles that you could be asked to do. One is where you've got a polynomial, and that's the first one we're looking at today. There's a second one, a type 2, where you're actually using a surd. Right, and then type 3 is when you've got a fraction. Alright, so the type 1 one with the problem, so the steps that we're going to go through is we're going to expand the bracket, we're going to collect the like terms, and then we're going to cancel the denominator. Right, so let's just have a go at doing one of these now. So if we've got this already set up for us now, the limit as h goes to 0, it's important that you keep that in there. If I expand this bracket here, x plus h squared, it's going to be x squared plus 2xh plus h squared. That's following that out. that'll be take x squared all over h. Now, I'm looking at this particular stage, this is the secret, is any term here which doesn't have a h term should cancel out. And if you've done it correctly, that will be the case. So that's a little checker for you. If you make a mistake, you'll have a term there that you can't cancel out. Right, so then I can say the limit as h goes to 0. Now what I can do is bring a common factor of h out. So that would give me h, 2x plus h all over h. Because I've got h on the top line and the bottom line, I can cancel that out. Alright, and then I can write this as equal to the limit as h goes to 0 of 2x plus h. Now, if I make h equal to 0 here, what happens? Well, it just basically gives me 2x. So therefore, f dashed of x is in fact equal to 2x. Where I've made this h term equal to 0, so it just goes out. So therefore, that is the slope of the tangent at that point. So in other words, if I'm thinking of my curve up here, if I wanted to know what the tangent was when x was equal to 1, that would be 2 times by 1, which would be equal to 2. If I wanted to work out what the slope of the tangent was when x was equal to 2, that would be 2 times by 2, which is equal to 4. And again, if I wanted to know what that was when x was equal to 5, it would be 2 times by 5, which is 10. So in other words, what we can see here is the slope of the tangent's getting steeper. And we would expect that's the case when we start looking at a quadratic curve. Alright, so the bigger the value x, the steeper the curve's going to be. Alright, so this is the general way of doing it. I could now put any value of x in here and I could work out what the slope of the tangent is equal to. Alright, I'll do another example for you in another video. So I'll just leave it there for now. And I'll be back with you shortly.